something is missing. Look at the center of this galaxy, not the edges, the center. It should be the brightest part. Every galaxy we know follows that rule. Stars pack tighter toward the middle. Light concentrates. The core glows. This one doesn't. The center of this galaxy is almost dark, fainter than any galaxy core we have ever studied. And the reason for that darkness, the reason the middle of a galaxy the size of dozens of Milky Ways is nearly empty, is something that took astronomers years to understand. Something ate it. This is Holmberg 15A, a galaxy sitting 700 million light-years from where you are right now. And at its center is an object so extreme that calling it a black hole, the way we usually use that phrase, the way it's used in textbooks and documentaries, doesn't quite cover what it actually is. It consumed the heart of its own galaxy. It hollowed out a region 15,000 light-years across and left almost nothing behind. And it did this not once, but over and over, across billions of years, across multiple galaxies, growing each time into something larger than the math says should be possible. By the end of this video, you will understand exactly what that means, and I think it will change how you see the universe and how unsettling it is that something like this exists, and we only found it recently. But before we get to what it ate, we need to understand what it is, because the numbers alone are enough to make you stop. Most people have heard of supermassive black holes. There is one at the center of almost every large galaxy. Ours is called Sagittarius A star. It has a mass of about 4 million times the mass of the Sun. 4 million solar masses sounds enormous, and it is, by any human standard. The black hole at the center of Home 15A has a confirmed mass of 40 billion solar masses. That is not a typo. 40 billion. 10,000 times more massive than the black hole at the center of our entire galaxy. To put that in terms, that means something. If you took every star in the Milky Way, all 200 to 400 billion of them, and added them together into a single object, you would still need to do that roughly 100 times over to match the mass of this black hole. This isn't just a big black hole. It belongs to a category that astronomers had to invent a new word for. Not supermassive, ultramassive, a category that begins at 10 billion solar masses and goes up from there. Home 15A sits comfortably in that category at 40 billion. And some older indirect estimates, using different measurement methods, have suggested the true mass could be as high as 310 billion solar masses. We don't know for certain. The direct measurement says 40 billion. The indirect measurements say potentially much more. Either way, this is one of the most massive objects ever confirmed to exist in the observable universe. The size of the event horizon mass and event horizon size scale together. Double the mass, double the radius. The event H, horizon of Sagittarius A star, the black hole at the center of our galaxy, has a radius of about 12 million kilometers. That sounds vast, but our solar system would swallow it completely. Mercury's orbit alone is 46 million kilometers from the Sun. The event horizon of Home 15A has a radius of approximately 790 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. Pluto, the outermost known planet in our solar system, orbits at about 39 astronomical units. The event horizon of this black hole extends to 790. That means if you placed Home 15A, where our Sun is right now, its event horizon would swallow every planet in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, and keep going. It would reach 20 times further than Pluto's orbit before the boundary finally ended. You would not be near a black hole. You would already be inside one. Every human being who has ever lived, every spacecraft we have ever launched, very radio signal we have ever sent, all of it inside. That is the scale of what sits at the center of Home 15A. But here is where it gets strange, because an event horizon that large should behave in ways that most people don't expect. And understanding that behavior is the key to understanding the most unsettling thing about this object. Most people imagine falling into a black hole as a violent, dramatic event. You cross some boundary and something happens. An alarm sounds in your body. You feel gravity grab you. You know, for a small black hole, that's roughly true. The tidal forces, the difference in gravitational pull between your head and your feet, would stretch you apart long before you reached the event horizon. You would feel it, violently and briefly. For Home 15A, the opposite is true. At this scale, the surface gravity at the event horizon is actually mild. The tidal forces are gentle. If you somehow drifted toward this black hole and crossed its event horizon,
sebagai yang jago curi waktu di kantor, ada 3 game yang gak bakal aku mainin.
drifted toward this black hole and crossed its event horizon, you would feel nothing change, no jolt, no signal, no alarm. The light from the rest of the universe would slowly gather behind you into a shrinking circle. The stars would shift, redden, crowd together into a tightening ring at your back. The universe in front of you would go dark. But you would feel none of this as violence. It would feel like drifting. You would simply pass a boundary you could not see, in a direction you could not identify, with no warning whatsoever. And then, you could never leave, not because something grabbed you, not because the gravity suddenly spiked, but because you had crossed a line in space where the geometry of reality itself had changed, where every direction, every possible path you could take, even moving at the speed of light, leads further in. There is no out, not because of force, because of geometry. The death would come later, somewhere much deeper in, hours, perhaps days after you crossed a boundary you never saw. The singularity, the poem, Inte, where the math of physics breaks down completely, would eventually find you. That is what makes ultramassive black holes like Home 15A feel less like objects and more like territories, less like predators and more like empires. You don't get caught by them. You wander into them. If you somehow drifted into the event horizon of Home 15A and felt nothing, would you want to know you had crossed? Or would you rather not know? Drop your answer below. Now we know what it is. We know what crossing it would feel like, but we haven't answered the question the title promised. How did something this massive hollow out its own galaxy? That story starts not with one galaxy, but with 8. To understand how Home 15A got this big, you have to go back billions of years, and you have to think about what happens when galaxies collide. Galaxies are not static objects floating politely in place. They move, they interact, they fall toward each other under gravity and merge. This has been happening since the early universe, and it continues today. When two spiral galaxies collide and merge, they form an elliptical galaxy. Rounder, less structured, their original spiral arms disrupted and mixed together over hundreds of millions of years. When two elliptical galaxies merge, something more dramatic happens. Their central black holes, which have been growing separately for billions of years, begin to spiral toward each other. They form a binary system, two enormous black holes orbiting one another at the center of the newly merged galaxy. And as they spiral closer, they do something extraordinary to the stars around them. Core scouring. When black holes empty a galaxy, imagine a gravitational slingshot. A star passes close to this binary black hole system. The interaction flings the star outward at enormous velocity, ejecting it from the central region entirely. This happens again and again, to star after star, thousands of them, millions of them. The process has a name: core scouring. The two black holes, by gravitationally throwing stars out of the center, gradually clear the core of the galaxy. The stars don't fall in, most of them get ejected outward into the galaxy's outer regions. What's left behind is a depleted, almost empty zone at the heart of the galaxy, faint, quiet, hollowed out. And then the two black holes merge into one, larger than either was before. Now most large elliptical galaxies have gone through this process once. They have a depleted core as evidence of one binary black hole merger. The core is faint, the black hole is big. Home 15A went through this process multiple times. Astronomers believe Home 15A is the product of at least two elliptical galaxies merging, each of which had already gone through its own core scouring event, each of which already had a depleted core from a previous merger. Trace it back further and the picture becomes extraordinary. Two ellipticals, each formed from two spirals, each of those S. Parallels, potentially a product of earlier mergers. The math suggests Home 15A may be the accumulated remnant of approximately 8 galaxies, 8 separate cosmic structures, each with their own stars, their own black holes, their own history collapsed over billions of years into one. 8 galaxies became 4, 4 became 2, 2 became Home 15A, and with each merger, more stars were ejected, more core was scoured away, more black hole mass merged into the central beast. The result is what we see now. A core 15,000 light-years across, wider than the distance from Earth to the center of our galaxy, that is nearly empty. The faintest galaxy core ever observed. A void at the heart of something enormous, not eaten in the way a predator eats prey. Emptied, cleared, slung outward by the gravitational violence of black holes colliding in slow motion over billions of years. That is what the thumbnail means. It ate its own galaxy, over, and kept growing. But here is what I haven't told you yet. After all of that, after 8 galaxies, after billions of years of mergers, after hollowing out a core wider than our distance from the galactic center, the black hole that resulted is still 4 to 9 times bigger than it should be. The math doesn't account for it, and that unexplained gap is where things get genuinely strange. When astronomers at the Max Planck Institute for Extraterrestrial Physics measured the mass of Home 15As black hole directly, using the movement of stars orbiting the center, they found 40 billion solar masses. Then they did something standard. They compared that mass to what the galaxy around it predicted. There are well-established relationships between a black hole's mass and the properties of its host galaxy, the mass of the stars in the central bulge, the speed at which those stars move. These relationships hold across hundreds of galaxies. They're how astronomers estimate black hole masses without direct measurement. They work, except for Home 15A. The team found that the black hole of Home 15A is not only the most massive one directly measured, it is 4 to 9 times larger than these relationships predict it should be. 4 to 9 times. That is not a small rounding error. That is not measurement uncertainty. The relationships that work for every other galaxy we have studied are off by nearly an order of magnitude for this one object. The most benign explanation is that the multiple mergers, the AT galaxy history,